Here's problem 823. A 1.2 kilogram mass is projected down a rough circular track, radius of 2 meters, as shown. The speed of the mass at point A is 3.2 meters per second. At point B, it's 6 meters per second. How much work is done on the mass between A and B by the force of friction? So we're assuming that there is friction between A and B, a rough surface here. And if we're looking at this mass, when it reaches point A, it's actually going to have a velocity equal to 3.2 meters per second. When it reaches point B, it's actually going to have a velocity equal to 6 meters per second. What we might be interested in is the difference in height between these 2 points, because we're going to actually choose level B as being our zero height level, and level A will be that height above that. Well, if we look at this, that same height will be the radius of that circular curve, because they are indeed parallel and of the same length. So this height h is actually going to be equal to 2 meters. Good to know. Okay, so we can set up our one equation to rule them all, and we have that the kinetic energy at A plus potential energy at A plus any work done along the way will equal the kinetic energy at B plus the potential energy at B. In this case, we do have kinetic energy at A because we're moving, and we have kinetic energy at B because we're also moving. Our potential energy at B is going to be 0 because we define that height to be 0, and we don't have any springs to worry about either. There is going to be work done along the way. That's what we want to find. So, solving for that, we have the work on the way is equal to the kinetic energy at B minus the kinetic energy at A minus the potential energy at A. And that is going to be 1/2 mass velocity at B squared minus 1/2 mass velocity at A squared minus mg height at A. That is going to be 1/2 times the mass, 1.2. Velocity of B squared is 6 meters per second. Square that, minus 1/2, 1.2. Velocity at A is 3.2 meters per second. Square that. Minus 1.2, 9.8. I'm running out of room here. And h is 2. Good thing. So what is that? It's negative 8.06 joules. So that is the work done by friction between point A and point B. A negative 8.06 joules. If I was trying to find the force of friction, I wouldn't be able to do it because it's changing constantly along this curve because the normal force is changing. So I would not be able to find the force in this particular case. But we have the work done by friction, that quantity, and it's a negative 8.06 joules.